Module 7, Lesson 5 is a continuation of where we left off yesterday, only now we're going to both write and solve one-step multiplication and division inequalities. The past couple of days, all we've been doing is solving them. Now we're going to be taking word problems and converting them into mathematical inequalities and solving them. If you take a look at our pacing guide for today, it says this should be a one-day lesson. Not too bad. Let's get started on it. The peregrine falcon is known to be the fastest member of the animal kingdom. During high-speed dives, it can reach speeds of up to 240 miles per hour. A bird flying at 240 miles per hour. Think about that. While traveling, peregrine falcons fly at an average speed between 25 and 34 miles per hour. From here it says the formula D equals RT, which is distance equals rate times time, can be used to represent the relationship between the distance and the time if the rate of travel is known. Write an equation that can be used to determine how long it would take a peregrine falcon to travel 200 miles at an average speed of 30 miles per hour. How can you solve this equation to find the time? If you knew the peregrine falcon traveled at most 200 miles at this speed, how can you transform your equation into an inequality? These are all some of the things we're going to be learning about in today's lesson. Ling earns $15 per hour working at the zoo. Write and solve an inequality to determine the number of hours Ling must work if she wants to earn at least $225. Then interpret the solution. Well, the key term here is at least. That means that her earnings could be greater than $225 or it could be exactly $225. What she doesn't want is for those earnings to be less than $225. So we're going to dig into this a little bit further here, and we're going to select some cards to talk about the steps for writing an inequality, and I suspect these are going to look kind of familiar to you. First, we're going to rewrite it in words. The amount earned per hour times the number of hours worked is at least, could be greater than, could be equal to, the amount earned each week. If we were to do that with variables, they said let X represent the number of hours, so we're going to define our variables here. I honestly would have used H, but they wanted X, that's fine. And then for the inequality, what they're going to have is $15 times some number of hours is greater than or equal to the 225. And we know this can be greater than or equal to because the amount that she earns has to be at least 225 or greater than 225. Now that we have got that part written as our inequality, we get to go back and actually solve it. And we worked problems just like these recently. We're going to isolate our variable, dividing both sides by the 15, which is going to look just like that. Now that's a positive 15, and because it's a positive 15, you're going to notice that the sign did not change directions. It stayed exactly like it was. From there, we're going to take and say 15 divided by 15 is 1. 1 times x, that's going to be x. 225 divided by 15, that's going to be, I think it's 15. Let me see if I'm right. Yep, I am right, it is 15. So x is going to be greater than or equal to 15. That's going to be your answer. Really easy to do these problems. The hardest part here is figuring out how to write it. After you write it, it's going to be just like the problems we worked the past 2 nights in our homework. Part C says to interpret the solution. So, to graph the solution, what are we going to do? We know that she has to make greater than or equal to $15, 15 hours, excuse me. So we're going to take, because it's an or equal to, we're going to use our solid circle, and we're going to put a nice color there, and we said she can work 15 hours, she can work 16, 17, 18, 19, she can work as many hours as she wants to, as long as she's working at least 15 hours. And this would be the graph of the inequality. Now it's going to be your turn to do extra example 1, which says Alex and Rowan are going on a 6-day hiking trip. and plan on hiking the same distance each day. They want to hike at least 75 miles total. You get to take and pause the video, write and solve your inequality, and then check your answer, and I'll get back with you in a minute. All right, did you get it done? Let's take a look at what I'm going to do. The inequality that can be used to determine how many miles X they should hike each day in order to hike at least 75 miles total. Well, at least also means greater than or equal to. So the total miles they're going to hike each day has to be greater than or equal to the 75 when you multiply by 6. So from there we're going to take and say, well, 6 times x, that's your 6 days, times the miles each day is less than or equal to 75. That's not going to get them the distance they want to go. This is division, not going to work, but check out this one right here. 6 times 6 days times the number of miles each day is greater than or equal to 75 miles. That is indeed going to be our answer. From here, now we're going to have to solve it. So I've written my problem over here. Well, I did. There it is. And we're going to take and work this out by simply isolating our variable. Our variable is w. His friend is 6. 6 is multiplying itself times w. So we're going to undo times 6 by dividing 6 on both sides. These 6's divide each other out, becoming 1. 1 times w is w. The sign does not change directions because we divided by a positive number. And then I'm going to come off to the side to do my grunt work here. 6 goes into 7 1 times. 1 times 6 is 6. Leaves 1 left over. Bring down your 5. 6 goes into 15 2 times. And 2 times 6, well, that's going to be 12 with 3 left over. So that's going to give you 12 and 3 6. So 12 and 3 6. Which also is known as 12 and 1/2 miles. So that means that each day they're going to need to travel 12 and 1/2 miles at a minimum. Now I just realized that I had a w in for a variable. They had an x in for the variable, but either way we're going to be good. X has to be greater than or equal to 12.5, and the answer checks. Easy math. Now the last thing we have to do is interpret the solution. So the interpreting the solution says that Alex and Ronan will need to hike at most, less than, approximately, there's that same word we had in our word problem, at least 12.5 miles each day, and that one checks as well. Now let's take a look at another problem. Miss Miller is buying wax to make candles. She wants to make, there that word is again, at least, didn't quite highlight everything, at least 35 candles. That means she can make more than 35 candles. She can make exactly 35 candles. But she needs to make at least 35 candles. Now taking our problem further, it also tells us that she needs 6.5 ounces of wax to make each candle. And it wants us to write and solve an inequality to determine the amount of wax she needs to buy and then interpret the solution. So let's get started in it. First off, we're writing the inequality in words. We know that the total amount of wax divided by the amount for each candle is going to be at least the number of candles needed. So from there, we could take and move that into variables. They defined the variable for x. They said let x equal the total amount of wax. And from there, they're going to take and set up their inequality. Their inequality was x, the total amount of wax they needed, divided by the 6.5 ounces of wax needed for each candle. It has to be greater than or equal to 35, because 35 ounces of wax, or 35 candles was what their target was. Now that we have the inequality, it's going to be time to solve it. Now the textbook got a little overzealous in showing the work here, but I think y'all can follow along with what they did. They had their original inequality that they created. They said, well, our variable x is being divided by 6.5, and we're going to undo divided by 6.5 by multiplying 6.5 on both sides of the equal sign. When they did that, these 6.5s divided out becoming 1. 1 times x was x. And on the right-hand side, 6.5 times 35. That gave them 227.5. So what does that mean? That means X, also known as the total amount of wax that they need, has to be greater than or equal to the 227.5 ounces. Moving on to the next slide here, interpreting the resource, the information. They want us to graph it. It's an or equal to, so that means we're going to need to have a closed circle starting at 227.5. X is greater than that number, so we're going to take that 227.5 and go greater than it, which grab ourselves a closed circle and go greater than it, and it's going to look just like that. Here's the graph. Easy math. Anybody can do this stuff. Now once again, it's going to be your turn to solve this problem where Carmen is buying ribbon to make wreaths. She wants to make at least 20 wreaths. There's that at least word again. And needs 10.25 inches of ribbon for each wreath. You need to write and solve your own inequality for this one and check your answers as you go. So in writing my inequality, the first thing I need to think about is, what is it asking us? It is asking, where's it at? Write and solve inequality, find out right here how much ribbon she should buy. We want the total amount of ribbon she should buy. And we're going to be dividing that ribbon into sections that are going to be 10.25 inches in length. So from there, we're going to need to find some place where I've taken and dividing the total by 10.25, and that's going to be option B and option D. Next, she needs to have at least 20 wreaths. That means greater than or equal to 20 wreaths. So with that, I'm going to come down here. This one gives me a number that's greater than or equal to 20. This one, it gives me a number that's less than or equal to 20. So B is going to be the answer to the first part of this. From there, now we need to take and actually solve it. So I'm going to jump over here, and I'm going to isolate my variable. The variable is X. His friend is 10.25. 10.25 is dividing X, so we're going to make that go away by adding 10.25, multiplying 10.25 on both sides. I'm going to do it after the numbers I'm doing it to, just like I've taught you to do. I also made a point to put this one at least in the middle, if not the top. These are going to divide out and become 1. 1 times x is x. Is greater than or equal to, and then 100, which is going to be 20 times 10.25. Well, that's going to be 20.5, which is going to be 205, I think, but let me go ahead and check that because I'm not positive on that one. So let me take and multiply that times 20. Of course, that's going to be 0, 0, 0, 0. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 0 is 0. And 2 times 2 is 2. We're going to balance 1, 2. And, oops, got to add these up. My bad. And bounce 1, 2. And what do you know? I am indeed right. X is going to be a number greater than or equal to 205. If I was to graph it on the number line at 205, is or equal to again. So we're going to have a solid circle. X is bigger than it, so the arrow is going to go to the right. Now coming back over here, I need X is greater than or equal to 205. Check the answer. Last part, Carmen needs what? She needs at least 205 inches of ribbon. And with that, we are done with today's lesson. Please make sure to work real hard on your homework tonight. Flag anything you don't understand so you can ask questions about it in class tomorrow.